Hello, I'm Christina. My project is called Sensor Data Assimilation, Supporting Decision Making in the Assessment of Embankment Dams. The project is about, dams, the safety monitoring of dams, and particularly the special type of them that is designed for storage of mining waste. And they look something like this photo here on the left. Basically, they are big dikes made of earthly materials, so soil, and they are designed to hold these big pools of muddy waters, which depending on the mining activity might be toxic. The problem is that they fail quite often. In fact, we have about 20 incidents per year, minor or major. And when they do, they might let out these vast amounts of toxic mud to contaminate rivers and water basins and kill fauna and flora around, and even kill people, as it has tragically happened too many times in the past. So this project is about developing technologies toward an efficient and reliable monitoring strategy for this type of structure. So we would like to create a tool that will be able to look out for trouble at all times during the operation of these structures and raise an alarm as soon as a hazardous situation is identified. So these structures are monitored using sensors, basically measuring instruments that are installed in different parts of the dam, and they measure important quantities such as water pressure, deformation of the material, etc. And thanks to advanced wireless technologies, they can now be read in a matter of minutes, so in real time, as we say, and they are automatically wirelessly transmitted so that they can easily be accessed by the people that are responsible for the monitoring and the management of these structures. But even though engineers now have an easy and continuous access to this data, sometimes it is not easy to interpret the data and actually decide whether the structure is safe or not. So the objective of my work is to develop the technologies for a software that will be able to answer this question exactly. So we would like to use all of our physical understanding and knowledge about the safety of these structures in order to create a virtual representation, a virtual replica, a model of the mechanics and the hydraulics that govern the problem. And this model should be able to receive measurements and in real time evaluate whether an alarm should be raised or not. Another interesting aspect of my work is this part about data assimilation. So as I said, in order to create these models, we need to use all of our understanding on the physics of the problem. However, sometimes it is difficult to know with certainty some parts of the actual state of the dam. So how can we even create an accurate model of the dam? So to solve this problem, the idea is to make the software smart in a way. So we would have it learn from the data it's receiving. The more measurements of pressure and displacement this software receives, the more it is able to sort of reverse engineer and deduce what are the conditions in the dam. For example, if we're not sure about some values of properties, mechanical or hydraulic of the materials that are in the dam, we might use data assimilation, this procedure, to do that. In this way, we might be able to correct our model and make it more accurate and therefore more reliable. I think that using this type of smart tool and smart technologies might be a real game changer for the safety of embankment dams. Thank you very much.